Okay, this is mostly chapter 13. There's parts of chapter 14 in this next section, which is essentially spinal cord and spinal nerves, or the peripheral nervous system, PNS. Okay, we've seen this diagram before, where we were talking about the central nervous system. But in this diagram now, what's highlighted is the peripheral nervous system. That is subdivided into the sensory division, which is afferent fibers, carrying fibers into the central nervous system, and the motor division, which is the efferent fibers carrying information out of the spinal cord. Now, the motor division is further divided into somatic nervous system, which is voluntary. Okay, you control that. You tell your muscles to move. You want to pick up something, you want to talk, you're telling your muscles to move. So somatic nervous system is voluntary, and it used to be called voluntary nervous system. And then the autonomic nervous system used to be called involuntary nervous system because it is involuntary. That is subdivided into two parts, sympathetic and parasympathetic. Now, your sympathetic nervous system is the nervous system that prepares you to fight an aggressor or run away from an aggressor. It's fight or flight nervous system. It is what kicks in when you are scared. You go to a scary movie, and every time something jumps out, that surge of adrenaline, that's from your sympathetic nervous system. The other, parasympathetic, is often called rest and digestion or rest and repair because it's more housekeeping. It governs your body most of the time unless you are under a lot of stress. So, sensory division, sensory nervous system, carrying information in. Remember, it's afferent, carries information from the peripheral into the central nervous system. We can classify the receptors because this is carrying information in, so there has to be receptors. There's mechanical receptors, and those are the ones that any mechanical change in them will cause them to fire. Okay. A good example is the Pacinian corpuscle, which is that deep pressure vibrating receptor. That one, if the receptor is changed by pressure or vibration, it fires. Okay, you push on your hand real hard, the Pacinian corpuscles their structure is changed somewhat because of that. Thermoreceptors definitely will fire based on temperature. Photoreceptors, of course, those are only in our eyes, respond to light, changes in light. Chemoreceptors fire based on some chemical in solution. Your tongue has chemoreceptors in it. Your nasal epithelial has chemoreceptors in it. You also have chemoreceptors inside your body, testing your blood, and that. Okay, so they're not just on the surface. And then nociceptors, those are the ones that your pain receptors are the ones they fire if there's tissue damage or there's very risk of tissue damage, it will fire. You touch something hot, just temporarily pull your hand back, it hurts because you could have damaged your body. Okay. We can also classify receptors based on location. Okay, so external receptors is outside. They take input from the outside of your body and send that to your central nervous system. You touch something, temperature changes. If it's cold outside, you put a coat on. If it's hot outside, you take some clothes off until you really can't take any more off. Internal receptors are also called visceroceptors. They're the ones that fire from inside our body. Now, most of the time, we're not aware of them firing because it's basic homeostasis, maintaining status quo in our body. Now, once in a while we do. You get the flu and your intestines are going really fast. You kind of feel some stuff. And then there's proprioceptors, and those are the ones that are basically in your skeletal muscle, tendons, joints, and it tells your body the status of those structures. Okay, and again, it's one that we don't necessarily are aware of what it's telling the brain. Okay. This is showing basically the structure of some of the receptors, because we can classify them based on structure. And basically classifications are whether or not there is a capsule or extra stuff around them. Now, the Pacinian corpuscle that I mentioned earlier is an encapsulated receptor because there's a lot of structure around it. So, the first one here, the first line, is a free nerve ending. In other words, it's just the plain nerve there. There's nothing extra, just the ends of the nerve. The next one shows a modified free nerve ending and then an encapsulated, and this, no, actually, this is not encapsulated. It's a nerve hair root plexus, which is free nerves around the root of the hairball, which, if you remember from the integumentary system, that receptor allows your hair to participate in the touch sensation. Okay, now, why are we not going? Oh, I know what I didn't do. I didn't even pull this up to full view, but we can keep going. So, receptor structure, complex receptors, special senses. Your retina, very complex. Your nasal epithelial, complex. Okay, and then simple receptors are either non-encapsulated or encapsulated. So, free nerve endings are non-encapsulated. Thermoreceptors, okay, nociceptors for pain, inch receptors, tactile discs, hair follicle receptors or root hair plexus. Those are all simple, non-encapsulated endings. This is showing encapsulated endings. There's a tactile or Meissner corpuscle, which is up in the dermal papillae of hair, of skin, hairless skin, participates in touch. But it's encapsulated. The Pacinian corpuscle, the second one down, very much structures around it, whatever. And then there's this last one, which I really don't talk about very much ever, and that one is basically deep in the hypodermis, dermis, and the joint capsules. But this is a ruffian ending. It's one that I really don't point out, so I don't really think that much about it. More other encapsulated receptors. The first one here is showing the muscle spindle, which is a receptor that monitors the level of contraction in the muscle. And we will talk about reflexes later, and those come into play. There's a tendon organ. I learned it as Golgi tendon organ. It's in the tendons. Its job is, just like the muscle spindle, is to protect the muscle and or tendon from overstretching. Okay, and there's joint kinesthetic receptors, and those basically is simply telling your body the angle of the joint. Okay, so Meissner's corpuscles, Pacinian, ruffian. I talked about each of these that's up here. And that's it for this little section. I know it was short, but we'll be back for more.